Everyone, as we have started 5 questions a day, so from today we are going to start this. And first question under this is the direction of the ray of light incident on the concave mirror is shown by PQ. Here you can see that PQ is the incident ray and it is passing through the focus of the concave mirror, and we know that if the ray is passing through the focus of concave mirror, it would become parallel after reflection. So most appropriate ray here is which is reflected, that is ray number 2. And the second question is, for second question, the focal length of concave mirror is f. An object is placed at a distance x from the focus. The magnification is. Now you see here some of the parameters are given. Focal length is f. As it is concave mirror, so focal length is negative. And second thing, the object is placed at a distance x from the focus. Let us consider focus is here. Object is placed at a distance x from the focus. So total object distance from the pole would become, this distance is small f, that is a focal length, and from here this distance is x. So distance of the object from the pole would become f plus x. So we can write object distance as f plus x with the negative sign as per sign conventions. Now magnification, we have to find out. Magnification formula is minus v over u. So u we have, but we need to find out v here. Using mirror formula we can find v. 1 over f is equal to 1 over u plus 1 over v. Or we can write 1 over v is equal to 1 over f minus 1 by u. So substituting the values, 1 over v is equal to 1 over minus f, and u here we have calculated as minus times f plus x. So minus minus would become plus, it would become f plus x. So little simplification, f into f plus x would become, this minus sign you can consider here. So this would become minus f minus x plus f. F would be cancelled and we will get v as, because this is 1 over v. So I want to write v here, taking the reciprocal of this, f plus x over minus x. So I can write minus sign here. So this is the value of v. Now I am having the value of u. This is u and this is v. Now we can write the expression of magnification. Magnification would be minus v over u. V is minus f plus x over x. And this one more minus sign is already there. And value of u is minus f times f plus x. So one more minus would come, that is minus f times, it is minus times f plus x. So you can see 2 minus would get cancelled and this f plus x would get cancelled. So we are left with minus f over x. So here option B is correct, this option. So option B is correct for this question, question number 2. And third question is, an object AB is kept in front of a concave mirror as shown in the figure. Complete the ray diagram showing the image formation of the object. So here we have to complete the ray diagram. Let us complete this ray diagram. Now you see, if you want to draw a ray, we can just imagine 2 rays. One you can draw parallel to principal axis. It would pass through the focus And second ray you can consider either passing through the focus and it would become parallel, or you can pass it you can pass this second ray from the optical center. It would remain as it is without any deflection. It would come back reversing its path. So it's up to you. Now for me, I guess focus is more convenient. So second ray is this. Now you can see you have to put the arrows whenever you're drawing the diagrams, this and this. Now these two rays are intersecting here, so here you would get the image here. So if this is AB, we would get this as the image. A dash B dash we can write. And second part of the question is, how will the position and intensity of the image be affected if lower half of the mirror reflecting surface is painted black? Now you see, if half of the mirror is painted black, means this is not available for the reflection. Only half of the mirror is available. So for half of the mirror, number of the rays which are going to make the image would be reduced to half. So all the rays are not going to give you the image. We have considered only 2 rays, but there are infinite number of rays. So only half of the rays would be meeting at this point. So it would reduce the intensity. So we can write here intensity of the ray would be reduced to half. And position, there won't be any change in the position of the image. It would remain as it is. So there won't be any change in the position of the image. But the intensity, yes, if only half of the mirror is available for reflection, only half of the rays are going to participate in the image formation. So intensity of the image would be reduced to half. Next question is, calculate the speed of light in medium whose critical angle is 45 degree. Here critical angle is given. Critical angle here is 45 degree and we need to find out the velocity of light in that medium. So from the critical angle, we can find the refractive index. As from the TIR, or total internal reflection topic, it is clear mu is 1 over sine C. So 1 over sine 45, C is given as 45. So refractive index of the medium is written as sine 45 is 1 by root 2. So refractive index of the medium comes out to be root 2. Now velocity of light from refractive index we can easily find. So we know that velocity of light in the medium is inversely proportional to refractive index of that medium. So this is C over mu m. So we can write this as C is 3 into 10 raised to power 8 meter per second and mu m is root 2, that is 3 into 10 raised to power 8. Root 2 is 1.41 meter per second. So this is the velocity of light and its value would be approximately, if you consider this as 1.4, it would comes out to be 2.1 approximately into 10 raised to power 8 meter per second. So this would be the velocity of light in that medium whose critical angle is given. And second part of the question is, does critical angle for given pair of media depend upon the wavelength of incident light? Give reason. Now you can see refractive index depends upon velocity. Velocity also depends upon frequency would remain constant and refraction, but velocity is nu lambda. So if velocity is proportional to lambda, as frequency would remain constant. So as a refractive index would depend upon velocity, velocity depends upon wavelength. So and critical angle depends upon the refractive index. So we can say yes, critical angle would depend upon the wavelength of the incident light. Yes, C will depend on the wavelength of the incident light. Okay, next question is last question. Last question is for the same value of angle of incidence. This fifth question we are writing here. For the same value of angle of incidence, the angle of refraction in three media A, B and C is 15 degree, 25 degree and 35 degree respectively. In which medium would the velocity of light be minimum? So here all the three media, they have the same angle of incidence, and you can see, let us consider this as the angle of incidence. It may have any value. So here also this angle is same, and here also it is same. And in this medium, angle of refraction is only 15 degree, and here it is 25 degree, little increased, and here it is 35 degree. So now this angle is 15 degree. Now you can see angle of incidence here is same in all the three media A, B and C. Let this media is A, this is B and this is C. Here angle of refraction is 15 degree, here it is 25 degree, here it is 35 degree. Now, in which medium would the velocity of light be minimum? As we know that the medium having the maximum refractive index would have the least velocity of light, and refraction would be seen here. Now you see here the bending of the light is maximum here. Here the bending of light is maximum because angle of refraction is least. So here bending of light is maximum and here bending of light is least if we are comparing the three media. So when bending is maximum, it means here it is showing maximum refraction. Maximum refraction can show only that medium which is having mu maximum. So here you see the refractive index is maximum here in this medium number A. Mu maximum, as we know that mu is inversely proportional to velocity of light in that medium. If mu here is maximum, so this conclusion will tell that V here is minimum. So this concept, using this concept, we can say that velocity of the light is minimum in medium A. So these were the 5 questions of today. Thank you.